So welcome to our next talk about finding vulnerabilities in closed-source PHP applications. Our speaker is Stefan Esser, and I'm very, very glad that he made it to the Congress this year. It was not easy to get it to talk about this topic, but I hope you enjoy the next one. Just welcome Stefan Esser.
Thank you. Okay, so welcome to my talk, Vulnerability Discovery in Closed-Source PHP Application. And for those that don't know who I am, my name is Stefan Esser. I'm from Cologne in Germany, and I worked for approximately 10 years in information security, and for 8 years I'm a PHP core developer. Last year I did the month of PHP bugs, where I disclosed every day of the month at least one security vulnerability in PHP itself. And I'm the author and maintainer of the Zuhu Sheen project, which is a security extension to PHP. And last but not least, I'm head of research and development of Sektion 1 GmbH, which is a German web application security company. So what is the talk about? I want to speak about PHP source code encryption, about how to recover bytecode from these encrypted PHP applications, how to visualize the bytecode, how to do vulnerability discovery within the bytecode, and finally I will also tell you that decompilation is possible. First, why do people encrypt their PHP application? The first thing is many enterprise companies want to protect their intellectual property, and therefore they don't want to give out source code even to their customers, and so they encrypt the PHP application in a way that you can't see the source code and you cannot make changes. The next thing is PHP source code encryption software is often used used by shareware authors. Shareware usually has some license system that needs to be protected so that you can't make your key file yourself. And then, like I said before, another reason to encrypt your source code is so that your customer cannot change the source code. Quite often when you have a large PHP application, you give it to the customer and they make custom changes, and then they call your support hotline and ask you about features you never implemented because they implemented them themselves. So the bugs are also their own. And last but not least, some companies encrypt their PHP applications because they want to hide their own intellectual property violations so that no one can see how and where they store code. So why do I care? The problem is, last year a customer for the first time asked me to audit an encrypted PHP application. Basically it was one of these shareware applications. He bought it and wasn't so sure about the security, and he gave the software to us, and we had to audit it, and at least the core libraries of this shareware product were encrypted. So normally you have no chance to get the source code, and you cannot do your usual source code audits on it. The next problem with PHP encryption tools is there are no public unpacking tools. There are some Russian or Chinese unpackers for some of the cryptors, but first of all they cost money, and secondly usually the GUI is in Chinese or in Russian, and have fun using them. Why do we care? We care because all the standard white box auditing mechanisms we are using, like a source code audit or like trying to hook some function and fuzz the application, they don't work with these encrypted PHP applications. On the one hand, there is no source code, so we cannot do a source code audit on these applications. And on the other hand, when we try to hook some functions like the MySQL query function and try to fuzz the application, suddenly our hooks will not be called because the engine internally works different with these cryptors available, and so our hooks will never hook, and so we will not catch the fast elements. And last but not least, if we find vulnerabilities in closed source PHP applications, first of all, not so many people can find these vulnerabilities, so you maybe have some real 0 days. And on the other hand, even if your bugs leak, only the vendor can fix it. So normally when you have a PHP application and it's open source, anyone who get to know the vulnerability can just change the source code and can fix the vulnerability. But with encrypted PHP applications, only the author or the vendor can change and fix the vulnerability. When I speak about PHP when I speak about encrypted PHP applications, I don't mean this like encryptions, like they just create some obfuscated PHP code and then they call the base64 decode function to decode some string and then they evaluate the string. This is nothing I'm speaking about, because this kind of protection can be easily defeated by just changing the PHP source code and hook the eval function, and you just output the parameter of the eval function instead of executing it, and then you get the original source code back. Maybe you need to step through several layers, but usually you get the original source code, and this is not really a protection. What I speak about is something that looks like this. Here you can see an example from a SendGuard encrypted file, and basically you see a PHP header, then some marker to give IDEs the chance to see that this is not a text file by just embedding some binary data in the beginning. And then you get a lot of nonsense PHP that does only print out a banner saying this one is an encrypted file, please download the loader there and there. And in the end, in the last 2 or 3 lines, you see binary garbage. And this binary garbage is actually the encrypted PHP source code. And you see there's no chance that you can get the original source code from that, and maybe you can try. But actually, this is encrypted bytecode, and there's no source code anymore. So, for more secure PHP encryption, this is usually implemented below the user space, because everything you do in user space can be hooked from within PHP, and you can just see what they are doing. So, PHP encryptions are usually implemented in a loadable extension, and you cannot run the PHP application without the loader extension. For example, with the SendGuard, this is the send optimizer. If your server doesn't have the send optimizer, you cannot run SendGuard encrypted files. And what SendGuard actually does is it takes the PHP code, compiles it, the resulting bytecode is encrypted with several layers, and so the source code is completely gone. You cannot recover the original source code from there. I have some pictures. So normally you have the PHP source code, which is green, and this gets passed to the send compile function. The send compile function will first tokenize it, then compile it, and the result is some kind of PHP bytecode, and this bytecode is then passed to the send execute function that executes the bytecode. So what happens when we load the SendGuard or the send optimizer? The send optimizer will, first of all, it will hook in between the PHP source code and the PHP compiler, and will replace the compiler with something that's called the Guardian compiler. And the Guardian compiler will first check before it compiles the code. It will first check if this is actually a SendGuard encrypted file, and if it's encrypted, then it will call its own routines. Otherwise, it will just pass the file to the original compiler. With old cryptors, this was everything that was done. So, The compiler, on the one hand, gives the original source code to the original compiler when it's not encrypted. But when it's encrypted, it just decrypts it and executes it. And with older encryptors, this execution was done by passing the decrypted bytecode directly to the PHP executor. And so with old cryptors, once you had hooked the execute function, you had the original bytecode and could work on the bytecode. With newer cryptors, the complete executor is replaced with something different. And so in this case, Send Optimizer executes this encrypted PHP and not the PHP engine. So there's some available PHP bytecode encryptors. These are only the three most known. This is first SendGuard from Send. Then there's the IonCube PHP encoder from IonCube, and Source Guardian from Source Guardian. And there are a lot of different cryptors, especially the people behind Source Guardian have a lot of white-labeled cryptors that are all more or less the same, but they sell them to different users to different prices with different names. So when you see one of those cryptors and you cannot really see who is behind it, then most probably it's one of the Source Guardian ones. They have a lot of strange companies in Eastern Europe, and every country has a different cryptor, and yeah, but most of them are developed by Source Guardian people. So PHP source code encryption usually exists on three levels. First, we have the simple encryption, which means the PHP bytecode is encrypted. Then the second level is some kind of obfuscation. So within the PHP bytecode, they obfuscate function and variable names. The bytecode itself is not obfuscated by the current cryptors, only the names. And last but not least, the newer cryptors have some protection. So like I already said, anti-hooking functionality so that you cannot simply fuzz the application. So far, I already spoke about PHP bytecode, but what actually is PHP bytecode? When PHP developers talk about PHP bytecode, they usually mean the opcode arrays. And opcode arrays are some internal structure within the Send engine, and they are the smallest compilation execution unit that exists. And within this structure, there's the function name this opcode array belongs to, there's the file name, and there's the line numbers this was compiled from. There's some type information like which kind of function, which kind of method this is a private, protected, or public one. And there are some other flags like if this is an internal function or a user space function. And of course, there are also information and about the function parameters. So within the opcode array, there's a table of allowed function parameters with their default values, with their type hints, if there are any, and of course, there's also the number of minimal needed parameters and the maximum number of parameters stored within the opcode array. And last but not least, there's of course the bytecode, which is stored in kind of op lines, which are the opcode lines, and I will come to that now. For every op line in the PHP bytecode stores exactly one comment. You have there the opcode, like in many other, if you know assembly language, you know that you have usually an opcode and some parameters, and in PHP bytecode it's the same. You have the opcode, there are about 150 different opcodes in PHP. They are all very high level, and then you have an optional result parameter, an operand, a result operand, and you have 1, 2, or 3 optional operands. Here on the slides you only see operand 1 and operand 2 because in the beginning there were only 2 operands, 1 and 2, but some of the opcodes require more operands and then they are stored in the extension value. And there are very few, like 3 or 4 opcodes that still need more operands, and then they take 2 opcode lines in the opcode array. And